All right, let's go ahead and start up, folks. I threw a syllabus on your desk. Congratulations on finishing the first class, pictorial views. You will have a few days to finish your last project. I think I'm gonna make it due on Thursday. Okay? So you got till Thursday. I want you to have time to push that a little bit further if you wish to, as far as the pictorial views. So if you're done with the house, go ahead and turn it in. If you want a little more time on it, you certainly have that, yes.
The pipes are due today?
Yeah, the pipes we need to get out. So let's get those turned in so that we can critique them and get them out, because those are going to require one more revision too before we hand them over to the welding group.
Yep.
Let's do our talk about tomorrow before we jump into the syllabus. So tomorrow we're doing the Agra Action layout. We'll start it at approximately 8:30. Again, come prepared for working in a fairly chilly, dirty environment. So don't wear your Sunday best, please, because you will be walking around. It used to be we followed the bowl sale.
Oh, that's great.
This year, now we follow the smoker, right? Wasn't the smoker this last weekend?
Yeah.
Okay. So we'll start that. Sean, have you had a chance to get over and talk to Steve about materials yet?
No, I was gonna do it when we were cleaning up, but everything was kind of hectic, and I did not. I can send him a text right now though, and see if we have that stuff, because Steve would know.
Yeah, if they're over there, that room is probably open, the maintenance room there, where all the tools are, and we can just walk over and look and see. I can go with you if you want me to, show you what we need to use to make that set. So, in essence, Sean, maybe get one other person to help you tomorrow. We'll have to make a run, probably to pick up some supplies. We'll determine what that is today. You'll need to get that money from the treasurer, who is now Juan, is that correct? The petty cash, to get that done.
How much money do we have petty cash?
Don't worry about it.
Well, because that one lady's messaging me and I told her to message you now, so.
All right, so we'll get that going. Now, as far as how we're going to organize it, Lisa's got the drawings done. She'll print those out today. We'll get those to everybody. I would show up here at 8 like normal. You'll have 20, 30 minutes to kind of get stuff going, and then we'll call it together and head over around 8:30, assuming that we can get into the building at that point in time. Anybody that has a long tape or even a shorter tape,
How long?
tape measure. So 20 to 25 footers are nice to have. We've only got one, that's mine. So if we have more, because we're going to break into 3 different groups. I've got 2 300-foot tapes, and I'll bring my 100-footer from home, but it would be nice if we had some more.
I have the real.
I think I've got
I've got one.
You've got what?
I think I've got 100.
100?
I think I do too.
You've got 100? So
Foot.
okay. If we could get you folks to maybe bring those, if they get damaged for some reason, then I would say that the club needs to replace those if they do get damaged. Like I said, we've got 2 300-footers back here, and I'll bring a 100-footer from home, so that will give us 5 tapes that we can work with. Majed, you have?
I have the same as you. The tape.
I don't
Okay,
have one.
yeah. And it's nice to have those little handheld ones also.
Mine are all at my mom's.
So if you bring some of those, make sure you got some identifier on them so that we get them back
Yeah.
to you before the day is over. Okay. Hopefully we all get over there and we pitch in and we've got it knocked out and you're back here by noon. Again, I think Andy, you're the only one that said you had a class. That comes before, so you need to cut out and do that.
Do you need a string line?
I think we've got all the string we need.
That'll do that.
Do you?
I'm fencing. Yeah.
If you got some that's going to waste, you might want to bring it, but I don't think we'll need it. We had a club, well, actually, no, we didn't, but I've got a whole thing of twine. Baling twine, and I'll bring that in, and that will
Oh, I got
take care of our
tons
long
too.
ones. And I've got some
Piles.
handheld 4 ones.
Do we need stakes or anything?
Stakes are over there,
Oh.
hammers are over there, all that. So all our materials should be there. They've got the chalker. We just need to get, as far as supplies, and paint and chalk. Okay, those are the ones we need.
We're meeting here before we head over.
Yes, we are.
Okay.
Yes, we'll meet here, get organized, and head out. And Sean, you'll probably leave it a little earlier so you can get to there and get our materials back to us. Okay. Any questions on that tomorrow? Okay, so that takes the place of class. Now, hopefully we get done a little sooner. You can come back here, and tomorrow's a short day. We're done at noon, but certainly if you wish to stay and work the rest of the day, that's your prerogative. No questions? Okay. Oh, I have asked that Lisa has finished the drawings, that she print them out, and somebody in the room double check the work, peer review. So if she asks you to look over that, please go through it with a fine-tooth comb and make sure she's got everything right. All right, let's jump into the syllabus. We're starting a new course. What I'm kind of expecting is that you spend half your workday on this course, half on your drawing. If you turned your drawing in from 148 the house, then spend all day on this. Right? All right, so let's go over the syllabi. Several drawings requiring the use of 3D geometric shapes and Boolean operators. Okay, so in essence, we're going three-dimensional for this course. Okay, now with that said, you're going to hear me say several times, stay 2D as long as possible. And that's really kind of the trick to drawing three-dimensional, is stay 2D as long as possible and then create your 3D shape at the end. Okay. Now, Boolean operators, you've probably never heard of that before unless you're familiar with recently with some math. This is a geometric term. It is basically math with geometry. Okay, do we add things together, shapes? Do we subtract shapes from each other? Do we get the intersections of them? Okay. You'll get more information on Boolean operators as we go. The drawings will require the use of AutoCAD construction and plotting techniques to include the use of multiple viewports and model and/or paper space. Okay. Real quickly, before I go any further, use of AutoCAD. We do have other 3D programs on your desktop, namely Revit, Civil 3D, SolidWorks. These are 3D packages. I've taught AutoCAD on this forever for specifically one reason, in that you go to the root of 3D design using AutoCAD. All of them work the same. They all use Boolean operators, they all require you to draw shapes, but they automate the process in these programs like Revit and SolidWorks. AutoCAD, you have to go to the root so you understand the entire process. Up until 2 versions ago, I would have also added that AutoCAD's the worst 3D modeler on the market. And so if you can model anything in AutoCAD, you can model it in any program. In version 2017 of AutoCAD, they totally revamped the 3D package. In my opinion, it's actually probably better than all these other packages now. In fact, I think with the tools you have available to you in this version, there's really nothing on the planet that you can't model effectively in a fast, efficient manner. It is really, like I said, they went entirely through the 3D package and updated it, and we've got more tools and shortcuts and things available to us than we've ever had in any program. In essence, I can't make that statement anymore that it's a bad 3D modeler. It's not. It's a great three-dimensional modeler. In fact, in my opinion, one of the best on the market. Certainly there are other programs. Okay. Drawings are intended to enforce techniques necessary to draft or design in the 3D arena using standards. Yes, we're still keeping those. Emphasis is placed on the construction of the 3D shapes and how to use them to provide finished drawings. Let's not ever lose sight of the fact that three-dimensional drafting is worthless to our readers. It is. We don't build off of a 3D model. That day's coming, but it's not here yet. We need working drawings at the end. And forever we've been on this. I was doing 3D drafting in the 80s. It's been around a long time. Most people couldn't do it in an office because the software was too expensive. You had to work for a company that allowed those things to happen. And I had the fortune to work for one of those. In the last decade, we've seen the cost come down, and namely the cost of your working PCs and memory requirements. Everybody is capable of working 3D now. Twin Falls has even gone 3D. Okay? And when that happens, you know the rest of the planet's doing it. Okay? Because you'll find this out when you leave the state. We are probably a decade behind on technology in a lot of places. We're doing it, every one of our firms around here are working 3D. So we need this skill to effectively go in. But bottom line, if we can't get this out of a 3D model, there's really no point in doing it. Okay? That is the big focus of this. Not can you draw it, can you produce working drawings? Yes?
So why is it so important to be just for visualization?
Yes, it was used as an engineering principle. We did a lot of 3D designs forever, and the workforce would never see them. But we could figure clashes where things interfere. We could get volumes, we could get densities, we could get temperature
Center of masses.
interactions, thermal properties, whether things would break or not, on an engineering principle, stuff that's done in the background. Okay? And that's all important to design. But it doesn't build anything, right? It allows us to kind of build a prototype digitally and try and envision how it's going to work. Ultimately, we've got to build it to really know. Okay? We can make some good educated guesses, and that's what's the engineering principles behind it.
So the engineer would give to the drafter, they do it 3D and say, oh, then they get back together and they say, wait, we might have a problem here?
Yes.
Okay.
Yeah, they'd say, oh, this part doesn't fit exactly, or I got too much clearance, because now we can physically put them together instead of doing intersections and all that stuff we did before. This is a quick visual tool for it. But ultimately, if we can't get working drawings and we can't build it, in my mind, it's worthless to us. Because remember, we're in a support role on the construction of items. We are to support the workforce. So that's where we need to make sure we get to. It's all great and wonderful to have this 3D model and spin it around and say, oh, this is a trick, I'm playing a video game. But ultimately, at the end of the day, we've got to pay the bills. And how do we pay the bills? We get something built. So I want to just kind of make it clear, we are going to spend quite a bit of time on that, and that is going to be the goal of it. We'll be about 3 weeks in this. We're going to move pretty fast. The text we're going to use is both of them. Primarily, we will be using this text. We'll be using, there's 2 texts in here. There's the basic and advanced. We will now be using the advanced section, which is the brown part that sits at the back. Okay? So that's our main text. I've still got the Bertolini text on here because this is a software text. It's not a drafting text. Specifically, I rate the chapters for it, but if you look down the bottom on the Bertolini, let me handle those first. On the Bertolini text, which is your drafting text, I've listed 2 chapters. We've already been over 5, which worked on 2D to 3D visualization. I'm adding chapter 9 on here. This one really has all the basics of what Boolean operators are, what's a wireframe, what's a surface, what's a solid. Okay. So by all means, I think there is some great information in chapter 9. I will probably not even go into this other than just to mention the terms. I think you ought to just scout through that one on your own. Okay. So that's that one. Now, as far as the Shoemaker text, which is your AutoCAD book, here's the chapters we're going to take, and we're going to take them in this order. We do chapters 1 through 4. I might get all the way through 4 tomorrow, or excuse me, Wednesday, because we're not doing anything tomorrow. Then we'll go 6 through 8. Now, the first part is introduction, 1 through 4. It's kind of learning where all your tools, your visualization, your design, how you look at things is. 6 through 8 is where we start building solids. You'll really like, I think, chapters 7 and 8, because now you're going to start seeing things really pop on your screen. After that, we'll go into editing mode. Once we've got a solid on our screen, how do we revise it or edit it? That's those chapters. Has kind of a neat section on 3-dimensional text. Okay, how do we do that? Text is not really 3-dimensional, but we can make it appear so. And it's, in essence, we're fooling AutoCAD. Chapter 14 is how we start printing, or how do we take these things and print them. And you're going to really like this, I think, because once we create the solid, we can actually tell it, hey, I want to look at this in a front view, draw it for me. And it will draw the 2D line work for you. Or it will display it in any fashion you want. You want a section through here, tell it, oh, draw a line here, project that line. And it will project exactly what it sees on the screen. Okay, so it will do all of the 2D line work for you. So printing, we'll spend quite a bit of time. We'll slow down through this process because there's 2 different ways to print in here, just so you know. I do say additional handouts may be provided. There's 2 ways to print. There's the old way, and then there's the new way. We're going to go over both of them. Okay. Last part is rendering. If we do have a solid, then we have the potential to create pictorial views also. Okay. And that is a process we call rendering. So it's going to be a lot like what you did with the house, okay, where we're going to try and create some artistic views that might go in a catalog or be used for visualization. Okay. I won't spend a huge amount of time on this other than just to say, here's the basics, here's how we're going to produce it. Okay. All those views up on those files over there, those are all renders of past students' 3-dimensional models.
In what program?
AutoCAD. So in essence, here's what we're going to take. Now, I mentioned spend half the day in this course, half the day on your house. That'd be Wednesday, Thursday. Start through these chapters. Notice I did take chapter 5 out of here, this class, and I'll kind of hit on it real quick. We're still going to jump into chapter 5, but I don't need you to preview it because it's already been covered back in the blue section. We hit it in 132. Okay. Any questions so far? A lot of chapters cover in 3 weeks. And in fact, we're going to cover them in less than 3 weeks because we're going to spend the last week doing nothing but drawing. Grading policy is the same. Instructional method, the same. I'll try and be done by 10 each morning. Okay, and then a quick list of items that in essence summarize the course. Setting up your grid. This is invariably, this one right here is the hardest thing for people to learn when you go 3-dimensional CAD. If you don't know this, AutoCAD is a constant 3-dimensional program. You've been drafting 3-dimensional all year. We just haven't used the Z dimension, but it's been there for our use. Now we're going to use it. And in year after year after year, I see this is the part that is the hardest for people to get. And that is, where am I at? What am I looking at? If I'm looking at a front view, am I looking at width and height? There's a reason, back to last semester, I spent so much time on this, and it was, in essence, to prep you for this. We start spinning that thing around into different dimensions. You've got to understand, hey, I'm on depth here, or I'm on height here, or I'm on width. We follow the glass box protocols. Okay. So again, we're going to be right back into that information. Nothing's going to change on it. Once you get this, how to set up a 3D grid and navigate it, the drawing's easy. Drawing's a piece of cake. Just lines. Okay. Without a doubt, this is the sticking point. So if you can get this, you're well on your way to being an effective 3D drafter. Okay. We're going to create a lot of objects. We're going to get in our Boolean operators. That's also in the create process. And then we're getting into the printing, multi-views. Yes, we can produce all multi-view drawings off of here. And that includes auxiliaries and section views. How do we dimension 3D? We do change this a little bit depending on how we projected our 3D model. Okay, so there's a couple ways we do that. And then we're coming into our pictorial views to finish off the class. So in essence, that's what we'll focus on for this. Any questions on that? Okay, let me just spend a couple minutes here. And this is straight out of chapter 9 of your Bertolini text. You don't need to turn there. I'm gonna write it on the board. In essence, when we start a project and we have something we need to produce, first thing we've got to do is make a choice. Are we going 2D or 3D on the object? That's always our first choice. Many times we'll choose going 3D, and we understand halfway through the project, we're gonna switch to 3D, or 2D, excuse me. We'll start 3D and then switch to 2D. And the reason for that is, think of a building like this. This was modeled three-dimensional, in Revit, actually. Do you think every nail that was used in this thing was modeled?
No.
No, it wasn't, no way. Do you think all the metal studs in that wall right there were modeled?
No.
No, because the cost benefit of doing all that just isn't there. Now what we can use it for is maybe the big block stuff. So I can come in and say, this is my room, I can model it three-dimensional, but I'm not modeling a door. I'm not modeling the handle to the door. And so we understand that 3D will benefit us in this route, but now I've still got to tell somebody how to build it, so I'm going to quit going 3D at this point and go to 2D, because that's our arena where I can do details, and I can look at it in sufficient detail to tell them where every bolt goes, every nut goes, every weld, all of this stuff. Okay? So this is the way a lot of projects work. We as understand, can't model everything. So you've got that choice. You may choose, if it's a very simple object, I'm not going 3D at all. That's the first choice. Second thing you've got to choose, let's say we chose three-dimensional, is you have to choose what type of model you are going to produce. There's several out there. And ultimately, this comes down to how much design goes into the object and what kind of information you need to make those choices. So the three models we have